Briefly demonstrate how to use interactive simulation that calculates equilibrium amounts where we have a heterogeneous reaction. So it's a solid calcium carbonate. When it decomposes, it forms solid calcium oxide, which is in a separate phase. This is important for doing the calculation. We assume calcium carbonate and calcium oxide are two separate solids. And when calcium carbonate decomposes, we get CO2 gas. So we're carrying out this in a constant volume reactor. It have to be at high temperatures to decompose calcium carbonate. And the simulation allows us to adjust the temperature. Even though the pressures are high, we're going to assume carbon dioxide is an ideal gas just to make the calculations easier. For these high pressures, carbon dioxide is definitely not going to be an ideal gas. So notice we're at high pressures for equilibrium at high temperatures. Because we're at high temperatures, even though we're at high pressures, the gas is not dramatically different, maybe at most 20 some percent at the higher pressures from ideal calculations. So we're just going to use ideal calculations just to make the simulation similar, but the behavior was certainly the same, just the pressure, actual value of pressure would be different because of non-ideality. So let's look at this simulation. So we're representing the gas as yellow. These simulated molecules are certainly moving much slower than actual molecules. The solids are in separate phases sitting at the bottom of the container. Let's go to lower temperature. We have mostly calcium carbonate, and not very much CO2 or calcium oxide. So as we raise the temperature, equilibrium pressure goes up and we get more CO2. And of course, we'll get to the point we can keep raising the temperature. Let's go back again. Let's start with less calcium carbonate and now raise the temperature. We'll get to the point where we used up all the calcium carbonate, so we raise the temperature more. Nothing's happening except the fact the higher temperature pressure will be higher for a gas, so that's a smaller change. Let's go back to condition. We have all three components. If I add more calcium carbonate, notice nothing is happening because the equilibrium pressure is 561 bars. So the equilibrium is not dependent on the amount, right? The fugacity doesn't depend on the amount as long as we have some present. So likewise, add calcium carbonate makes no difference in behavior. If I add more CO2, notice I don't change the pressure, but I decrease until I get to the point where now if I add more CO2, it just goes into the gas phase. We're above, if you like, the equilibrium pressure. We can't decrease it because we have no calcium oxide to react with the CO2. If I add some calcium oxide, then the pressure will come down to equilibrium pressure. We'll get back to all three phases present. So heterogeneous equilibrium, we have to be mindful of how much we have of a given phase, but the concentrations of solid, the amount of solid doesn't affect their fugacity because the two solids are in separate phases.